The title of our last video was how to make a cloud, but I didn't exactly share with you how to make a cloud. I was really thinking about it and I decided I'm going to share something special with you. A recipe that's been passed down generation and generation in my family, and I think it's time I share it with you. This is Binder's recipe to make a cloud. It's easy. You can do this at home. You only need 2 ingredients. The first ingredient is water. And there's lots of water in the atmosphere, so that's pretty easy. Lots of water in this room. I can get that. The second ingredient is dust. Dust. We need something for the water to stick to. Now, scientists don't like to call it dust. They've got to make it more complicated than it needs to be. But scientists will go by CCN. That stands for Cloud Condensation Nuclei. That's really important. If there's no dust or CCN, you won't get a cloud, no matter how much water's in the atmosphere. It acts just like this can of soda, which is under pressure. Now watch what happens when we put it in the glass and add some CCN. As you've seen with any soda before, it's saturated with carbon dioxide that starts to fizz when we release any of the pressure. Those bubbles are inside just waiting to stick to something. In this case, some of them are sticking to the sides of the glass as we speak. So if I introduce some dust or some CCN, give those bubbles something to stick to, it should foam up. And that's what I have this sugar for. Let's take a look. Add a pinch of sugar. Look how it foams up. The little bubbles of carbon dioxide are trying to stick to the CCN. And that's exactly why we need dust in the atmosphere. So the water has something to stick to, and that's what makes a cloud. And like any good recipe, once you have the ingredients, next you have the instructions. And here we've got 2 simple steps. First, you mix those 2 things together, then raise the relative humidity to 100%. And I can do that here in this room. I've got a container for my cloud right there. And I have ingredient number 1, some water, which I'll dump in there. And now I need some dust, and that's what the matches are for. Simply strike the match and drop it in. Now I've got plenty of dust. Now I've got to get the relative humidity to 100%, and I've got a little trick for that, little cleaning glove. See, I know something about how air pressure works. I'm going to try to decrease the amount of volume inside this container, and that in turn is going to increase the relative humidity inside the jar. So I'm going to pull up on this on the count of 3, and watch inside. You'll see a cloud. Now it's not going to be foggy. Only 4% of what's in this jar is water vapor. So it's going to be a thin cloud, but if you look at the black background, you should be able to see it. Here we go. 3, 2, 1. There we go. Do you notice how quickly it formed like that and went away like that? We'll try it again. 1, 2. A real simple experiment, cloud inside a jar. Now in nature, how you get the relative humidity to 100% is actually a little bit simpler. So we have the mixture of dust and water vapor already in the air. So we just take our piece of air and lift it up in the atmosphere where it's colder up there. We'll bring the temperature down to the dew point. It looks something like this. This little box of air that's at 92 degrees, it has a dew point of 60. That's the amount of moisture in that box. As we lift it up, the moisture content's not going to change. So 3,000 feet high, the temperature drops to 76 because we're leaving the ground. The dew point's still at 60, and at 6,000 feet in this case, when the box gets to a temperature of 60, it hits the dew point. You're at 100% relative humidity, and just like that, you get a cloud. That's why the clouds are up there. It's possible that we won't get a cloud even though the relative humidity is at 100% in a rare case. In fact, that happens when we have hydrophobic nuclei. That's water-repelling nuclei, things like oil and gasoline. So air pollution helps inhibit the formation of clouds. It's just a little bit. We can also have clouds form early when the relative humidity is not quite 100%. That's with what we call hygroscopic nuclei, little CCNs that seek out water, kind of like that dust in that little packet that says do not eat when you buy your shoes and they come in the box. Or silver iodide, something you've never seen, but they try to seed clouds with it in the West. Or something you have seen, salt. When you add salt to something, it tends to absorb water. That's why in some restaurants you've seen salt shakers with rice inside. The rice is preventing the salt from clumping together after it absorbs that water. In fact, if you open a bag of potato chips that are salty and you leave it open, they tend to get soggy because the salt in the chips absorbs the moisture from the air around it. So fog happens then when we're inside a cloud. The visibility is under 6 miles and the temperature and the dew point are very, very close. Now there's other things where we can't see because of a cloud, but it might not be natural, right? You could have haze, for example. Haze happens when the temperature and the dew point are close, but you can still see pretty far. Haze also has smaller drops than a typical cloud. Now, if the temperature and the dew point are far apart and we can't see, then we have smoke from like a forest fire or car exhaust or from a factory. When smoke inhibits our ability to see, we call it smog, a smoke fog. Volcanoes also do this. We don't have volcanoes around here, but in Hawaii they have something called VOG, a volcanic fog, something you really don't want to breathe in. Now in 1802, Luke Howard was the first person to classify clouds, and he used the Latin language. At Penn State, I took a course that lasted 15 weeks, 2 times a week, just learning about clouds. I can teach you almost all the clouds, I believe, in just 5 minutes. So what I want you to do is just take a moment. Okay? Close your eyes. Picture yourself in a field somewhere. It's a nice warm day, and you look up in the sky and you see a cloud. Focus on that cloud. Now, out loud, say in one word a description of that cloud. Most people will say puffy, some will say white, some will say curly, wispy, like cotton candy. Typically, most people see the puffy white cloud. Now, there's really only 3 basic types of clouds, and that's what I want to go over next. There are the cirrus clouds. Cirrus means curly, and they're the clouds that look basically like this. They're up high in our atmosphere, made mostly of ice. Cumulus clouds are the puffy ones. They look like little cotton balls in the sky, with pieces of blue sometimes sneaking in between them. And some people envision a low, flat gray cloud, one large, dark, flat cloud, or straight cloud. That's the stratus cloud. All the clouds in our air are a variation of one of these 3 kinds of clouds. And what's great about Latin is we can combine the Latin words together, take out the us, and add an O. So a puffy, curly cloud, it doesn't matter if we say puffy curly or curly puffy. Well, curly is cirrus, puffy is cumulus, so put that together and we get cirrocumulus. Or you could also call it cumulocirrus. It's the same thing. A flat and puffy cloud would be the word stratus and cumulus together. Stratocumulus or cumulostratus. It's the same thing. Here is a cumulostratus cloud. It's flat, but you can see some puffiness to it. All 3 together. A flat, puffy, curly cloud. Stratocumulocirrus cloud or cirrocumulostratus, or wow, there's a lot of different variations that we could have. So right here you see a cumulostratus cloud, flat and puffy. Here you see a flat layer of cloud that looks curly, cumulocirrus. Here you see those wispy curly clouds, but they look a little puffy at the same time. So cumulocirrus. In 1887, we added another prefix because some of the clouds were really high in the atmosphere and some were really low, and then others were in between. So Abercrombie and Hildebrandt wanted to have an in between, right? Cirrus was high, cumulus and stratus were low. So alto meant they were in the mid-levels. So you could have alto cirrus, alto cumulus, alto stratus. And all the other clouds are just a combination of other kinds of Latin words. Like nimbus means raining. So a cumulonimbus cloud is a raining, puffy cloud, typical in thunderstorms. Notice the flat top on it. The tallest clouds in the world are cumulonimbus clouds. They reach up to 59,000 feet, and that happens in January and February in the South Pacific. Here in Pennsylvania, our clouds normally go up about 30,000 feet, something you can fly over. Here are the other prefixes, and you can see where their words come into our English language. Fractus is like fracture or broken. Translucidus is see-through. Humulus, humble and small. Congestus, clumpy and sticky. Castellanus, castle-like. Lenticularis, lens-like. Undulatus, wavy. It goes on, and you can come up with huge names for clouds and sound very impressive, but you're just throwing adjectives together. Like this, altostratus or altofractostratus, a mid-level broken flat cloud. Or this, a cirrostrata translucidus cloud, a wispy, flat, see-through cloud. Or this, a cumulocongestus cloud, puffy clouds that kind of got stuck together, a precursor for some thunderstorms. Or a nimbostratus, a stormy rain cloud. Or wow, a cumulolenticular undulatus cloud, a wavy, lens-like, puffy cloud. The list goes on and on. So it took me 15 weeks to learn that. Hope you find some of that interesting. Next time you're out with your friends, you can look up at a cloud and impress them with some Latin. Another word is pileus, which means cap. And when you see these on top of those storm clouds, that lets me know that that's a real dangerous storm. There's a lot of vertical motion in that storm. It's very unstable. You have mammatus clouds, mammal-like, kind of like a cow's a mammal and it has udders. Well, these clouds kind of hang down from the base. A contrail, that's not Latin, that's English. Condensation trail. That's what's left behind an airplane as it flies through the sky. They actually affect our temperature. In fact, after the terrorist attacks on 9/11, they actually found more sunlight hit the ground in the absence of those contrails, and our average temperature rose 1 to 2 degrees. And scud, these fibrous clouds that look menacing under another cloud, kind of like this. Some people look at them and they think they're part of a tornado or part of a severe storm, but really they're kind of harmless. When we look at the clouds, we can define the type of weather based on the coverage of clouds in the sky. If there's no clouds in the sky, it's going to be clear. 25%, just a few clouds. Up to 50%, that's scattered, partly cloudy or mostly sunny. They mean the same thing. A little more than half, it's mostly cloudy or partly sunny. And then if the sky is covered, it's considered overcast. So now I hope you've learned a little bit something about the clouds and you can impress your friends the next time you're outside, or maybe not.